Hello, and welcome to Research Methods. My name is Cody, and I'll be guiding you through this basic guide to forming research questions. Research question. Well, let's start with the question. The research question. Now, this is very important to understand. A research question is the question that pinpoints the phenomenon that is being studied. Let's have an example here. How do bears retrieve honey from beehives? Now, this may seem like a silly question to ask, but being a silly question might help you understand some other basic concepts later. A research question typically starts with an idea of what you are interested in studying. In this case, bears and honey. What do we do following the development of this question? Well, let's go back real quick to the definition of science. This comes from the internet, so just Google it and you'll get the same thing. Science typically helps us study the world in a systematic way by observing through our five senses, which leads me back to empiricism. The theory that all knowledge is derived from sense experience. In general, it is defined as the process of acquiring knowledge through experience and observation, blah, 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 blah. If you want to know more about basic science concepts, you can see my previous video that will be listed in the same playlist. Alright, so what's next? So we've had the quick recap of what science is. For a more full explanation, as I said, see the previous video, and it'll also explain why we don't use the word prove. Okay, so how does that help? Well, we have this research question, right? How do bears retrieve honey from beehives? Now that we have that and we reviewed science, what should we do now? Well, we're going to develop a hypothesis. You may be asking yourself, what is a hypothesis? Well, it's a good question. It's going to be answered on the next slide. As you can see, hypothesis. Since I often love to see what Google has to offer, I asked Google what a hypothesis was. The first thing that it lists is a hypothesis is an educated guess about how things work. Second, thing that it provides is a way to form one. It's kind of a general cut and paste guide, which may not be so good in the professional sense, but just to help get yourself situated, it works out great. This is actually the same form I used when I was in high school. Then it says that in order to be a hypothesis, it has to be testable. Now, this setup for a hypothesis may be a bit, as I said, elementary school science fair, but it is a good starting place, I think. It is the model we used, as I said, in like high school science class. But don't use it for publicizing. Okay. So let's try out. We'll just kind of start from there. We have our research question. How do bears retrieve honey from beehives? Well, we're going to turn that into a hypothesis by making an educated guess. We're going to try using some if-then statements, and then we're going to see about testability. So, an example would be if a bear wants honey, then it will use any means necessary to obtain it. This meets all the qualifications, but I still wouldn't call this a really good example. So we're going to refine this a little bit. Okay, here is our first hypothesis. And the refined one. Now, this refined hypothesis still is testable in a way, and it uses an educated guess about how things work. But it's also more specific. It really targets what you're looking for. So bears use their claws to climb trees and obtain honey from beehives in high places. Other than, any means necessary. Gives you a more targeted focus, which makes this arguably better. Now, there is one thing that both of these still kind of lack that I would say a good hypothesis would need, and that is directionality. Directionality would, in the sense of research, refer to the relationship between the variables or the direction that relationship is going. So we're going to refine this hypothesis to find to something that infers a relationship. So here we go again. All right. Bears in reality will use claws to climb trees and retrieve honey, while cartoon bears will use tools to get honey in any way possible. So it's testable, it's an educated guess, and it also insinuates the relationship between the variables. Now, as I said before with the if-then statements, they're a good basis, and you can kind of build up from it to get to this kind of point. But I'd like to point out a word that I keep using, and that's variable. Well, what is a variable? We're going to go over that now. It's important to understand what a variable is when you're developing your hypothesis, because typically you're wanting to test this hypothesis. Now, the definition of a variable is a characteristic that can differ or change. Now, your basic experimental design is going to consist of independent and dependent variables. An independent variable is the presumed cause in an experimental study and is the variable that is manipulated by the experimenter. The dependent variable is the presumed effect in the experimental study, so the results of the dependent variable are dependent on the independent variable. So our independent variable is going to be the type of bear in the previous scenario, and then our dependent is the method of honey collection. Now, as I said, these have to be testable. A good basis in most research cases is going to be looking for falsifiability. What a word. I messed it up there for a second. I say a lot too. Apologize for that. But anyway, falsifiability. It is described as an assertion that is testable if we can envision gathering some type of empirical evidence that will reveal the assertion to be false, which is a mouthful, but that's like a textbook definition. They often are. But basically, it is falsifiable if you can prove it to be wrong with evidence. This is a useful concept when thinking about hypotheses and experiment designs. We set them up to fail in order to demonstrate what is going on. So, for our example, it's actually very easy to falsify this, because if a bear, like a real bear, uses a tool such as a tree branch, breaks it off or whatever, and uses it to bat down the beehive, well, it automatically falsifies our hypothesis. So it's falsifiable. It is easy to test. We're going to give it another example. So in this example, we may not be able to prove that the potion gives immortality, but we can disprove it. Now, it says it may very well bring about immortality, but it will take forever to test it. So this is an example of how it's supposed to work. In order to falsify it, in order to test it, you have to be able to falsify it. Something like this isn't falsifiable. I mean, not really anyway. There are some ways you could speculate on how we can do that. But not ethically so. Anyway, so from here we're going to move to types of research, because as I have mentioned, the experimental design a few times varies. So you got your types of research. You have experimental research. And this is just going to be the basics, but you have experimental research and then correlational research. Correlational. So your basics are experimental and non-experimental. So non-experimental is typically going to be like correlational research. In experimental research, there is at least one variable that is manipulated to test and see if there is an effect on the second. In experimental research, statements can sometimes be made about cause and effect as well, because you're controlling what is going on. In correlational research, these observations are typically made about the natural world, and there is no manipulation or interference, so you cannot make assumptions about cause and effect in those cases. Then you have somewhere in between, which is what we're doing. We're doing a quasi-experimental setup here. Nothing is really manipulated, but you have separate groups. So using our example, you have your bears that are just kind of naturally occurring. We did not place them in their groups. They are just in those groups, but we are studying them as separate groups to see how they do things. Gender differences, whenever you study gender, is also a quasi-experimental typically, if you're focusing just on gender, because that's another characteristic that you can't just assign to people. You can't just say to someone, okay, you're female now and you're male now. Now go do these things. It doesn't work that way. Same with the bears. If you could see me right now, I'd be doing a bunch of hand motions. I'm really good with the hand motions. All right. This is going to kind of shift gears just a little bit, because we need to address theory first. So what is a theory? Again, this is directly off of Google. Theory definition. In science, an explanation or a model that covers a substantial group of occurrences in nature and has been confirmed by a substantial number of experiments and observations. A theory is more general and better verified than a hypothesis. There's a few that it lists there. So a theory is a set of formal statements that specifies how and why variables or events are related. Well, it is... We're going to break this down a little bit. It is a lot like a hypothesis. Theories are much broader, though. They can be used to derive many new, often more specific hypotheses. They cast a wide net, such as these various examples. But theory is most importantly, as far as science is concerned, based upon repeated results from testing hypotheses. As it had said before, it has support for it. So for many theories, large amounts of data are gathered that support the theory and little to go against it as far as theories that are accepted and still in use. It can be helpful to consider more scientific theories like Einstein's theory of relativity. People don't argue that it's not a thing because it's been supported in science. I know more recent research has kind of pushed away from that, but it's a little beyond me and the subject matter here. But it is based on working knowledge of the subject and is generally accepted as true. So you've got Piaget's theory of cognitive development, Erik Erikson's stage theory of psychosocial development, and then Pavlov and classical conditioning. These are all things that are considered theories, but when you use the word theory, it's not the same as a hypothesis. It is something that is generally accepted as true, or at least that is the way that I like to think of it. So we're going to go over this. You're going to have to just excuse this a little bit. But it is not just a theory. So this is going to be a bit of a rant here. That if you haven't heard in any basic field of science, like collegiate level, I suppose, is when I first started hearing this a lot more, then you're probably not listening. This is a valid rant, so we will call it a strong fact or reasoning for anger or disgust at the general population. It is the idea that people have, the misconception that theories are just some person's ideas or opinions and are not truly based on anything. Kind of like coming up with a hypothesis or a research question. It's people pretend that they're not valid. It's kind of like the Big Bang Theory or theory of evolution. Those, you can't just say, I don't believe in it. Well, that doesn't work that way. Lots of evidence has been gathered to support those things. So by saying you don't believe in it, you're just ignoring facts. Theories, as stated previously, are based on repeated trials and the collection of evidence through the process of science. I hope that makes sense now, and I hope you realize that this also means that you cannot and should not use a particular phrase that a lot of people use in the common vernacular, which is, I theorize about something. It's okay to use that in the common vernacular, I guess. You could argue on that one too. But it is not okay to do that in research, because then you're saying that, well, I have this theory because I've done a bunch of things. Typically, when you're doing an initial research project, which most of the people that would be viewing this would be working on, because this is for an introductory research methods course, you're going to be looking at the phrase "I hypothesize." So you should not use the phrase "I theorize" in your research papers. Sorry, dude, you do not theorize anything, you were just hypothesizing. So, we're going to kind of go over this a little bit. We've got research question, hypothesis, null hypothesis, variables, and research type. Alright, so this is editing me. The null hypothesis is gone over in the previous video for this section of playlist, but basically the null hypothesis is the hypothesis that says whatever you're hypothesizing doesn't exist. So, our research question, our new one, is: do men and women eat more when they are dining together? Now, this is a real study. I actually heard about it on the radio, and it is very interesting. I love hearing things on morning radio. Men eat more in the presence of women, and these are the hypotheses. Men eat more in the presence of women, and women eat less in the presence of men. That's our hypothesis. It's directional. It's making an educated guess. Then you have the null hypothesis. There is going to be no difference in the amount of food that either gender eats in the presence of the other. Now, what are our variables? Ivy, independent variable, gender. So, as I had talked about before, this is not an actual experimental design. This is a quasi-experimental, as I noted here. I'm going to jump ahead myself a little bit. And the dependent variable is going to be the amount that each person eats. As I said, it's a quasi-experimental design, and it is so because it has aspects of both correlational and experimental. We are not manipulating anything, but we are separating things out into different groups in order to identify some characteristic. Let's have another go. So, research question, hypothesis, null hypothesis, variables, research type. Research question: do children that are given extra materialistic items have greater behavior issues? Basically, do children that are given extra toys have greater behavior issues in a given day? Our hypothesis: children that are given more stuff will have less issues throughout a day. Sounds fair. Null hypothesis: the amount of behaviors noted in a day will not differ between children who are given extra stuff and those that are not. I'm running out of liquid. I'm sure you needed to know that. So our variables would then be, for the independent variable, the group. We are actually manipulating this time. We are separating kids out. One group of kids is going to get more toys than the other group of kids. And then we're going to note if they have any behaviors and just sort of assume cause and effect from that. Now, if you want a real good experiment, you're going to have to do more than this basic stuff, but this is just basic. So our research type is experimental because we are placing the children in the groups and therefore manipulating the independent variable. That worked out really well. The drop down. So now we're going to build a theory off of that. Since we had our small rant about theories, I think we should go over them a little bit. How can we build a theory off of this? Well, here's our hypothesis. From here, we're going to collect data, and then let's say that we find the opposite is true. And that this is found to be true on repeated trials with varying demographics. So you have a lot of evidence to support the fact that children are having more behavior issues throughout the day as they are given more items. We're not really looking at why, although you can kind of work with that if you do more in this type of experiment. But okay, the opposite. What would you theorize? So it's the opposite, as I said. So children that are given more stuff will have more issues throughout the day. So what would your theory be? Take a minute to kind of figure that out. Should come pretty close to something like this. Children that obtain more items in a given day tend to have more behavior issues throughout that day due to potential feelings of entitlement. It could be due to just being spoiled. Something like that. You want to kind of come up with an idea based off of your evidence and build a theory on that. And since you have support for all of it, you can build a pretty good theory. And so we're going to kind of recap here after this baby gets done passing the screen, because I was supposed to play sooner. But it's okay. So recap. What is a hypothesis? Hypotheses are tentative statements about how the world operates and are subject to empirical testing. Now, this is a textbook definition. Variable. Any factor or attribute that can assume two or more values. And then you have the two different kinds of variables. Your basic variables. There are many names for different variables. You have your independent variable, the variable that is manipulated in an experiment or is being controlled. Then your dependent variable, the outcome variable, the variable that is affected by the independent variable. It is dependent on the independent variable. It's like codependency. The dependent variable cannot survive without the independent variable. Or at least that's what you hope. That's what you're trying to test. Then you have, I want to go over this again, falsifiability. You hush. You're probably being picked up on the microphone. That was Cat. Falsifiability, way that it is used to see if a hypothesis or research question is testable. A little more recap. We have the research types. You have your basics here. Experimental, correlational, and then quasi. Experimental manipulation is involved. Correlational, observation of the natural world. And then a quasi-experimental, which is what our bear experiment was. Theory. Theory is a set of formal statements that are considered to be held true as they are backed up by experience or research. So hopefully when you're using the common vernacular, you are going to say, well, I theorize, and you're able to say that because of some sort of experience or research. And that's just about it. Don't forget, it is not just a theory. You cannot use the phrase in your research papers, I theorize. You don't theorize, you're hypothesizing. Just remember that. Now, if you personally are building up all of this, sure, go for a theory. But that's going to be a different type of write-up anyway. That's all the time that we have. Once again, my name is Cody, and I will see you in the next video in which we go over random assignment and random sampling. We're going to have to refer back to some of this. So I'll see you in the next video.